All right, good morning, Algebra 2. So it says decide if each of these equations is true or false for x values that do not result in a denominator of 0. Be prepared to explain your reasoning. So the first thing, if I plug in 0 in this denominator, that's going to give me undefined. Okay? And undefined is equal to 1 plus, if I plug in 0 down here, it's going to be undefined. So x cannot equal 0. Okay, that's the first thing I want to notice right off the bat because I don't like undefined. It's not my favorite. But if I were to solve all of this, I got to have the same denominator across the board. So that means that I would have x plus 7 over x. And for this to have the same denominator as this, I would have to multiply by the common denominator, which is x. So this would be x over x plus 7. If we have the same denominator, that I can take everything on top and I can just add it together. So recap really quick, because I know a lot of people freak out about this x over x. Notice how x divided by x is just going to give me 1. I'm having to change this 1 to have a common denominator with this guy. So this is going to be x plus 7 over x equals x plus 7 over x. Okay, so you see how both sides are equivalent? So it says decide if each of these equations are true or false. If they're the same thing on both sides, then that means that they're going to be true. Okay? And find for x values that do not result in denominator of 0. So they're true for all values because I can plug in any x value, except I can't plug in that 0 because that'll give me a denominator of 0. And that's a bad thing in rational functions. So this unit in particular, we're talking about rational functions. Okay? And with rational functions, that's going to look like a fraction where there's an x in the denominator and then there's an x either in the top or it's just a fraction with an x in the bottom. Okay? All right, so looking at number 2. Again, we want the same denominator across the board, but see how there's all 3 different denominators. So you're going to take each of these and make sure that you multiply it in the top. So for instance, this guy over here is missing an extra 7 in the denominator. So we're going to take 7 and we're going to multiply it by this fraction over here. So 7. And if we do something in the top, or do something in the bottom, we have to do something in the top as well. Okay? Over here, we want a 7 and we want x plus 7 in the denominator as well. So we're going to have 7 and x plus 7 in the top and the bottom. For that 1, notice how if I take this and I divide it out, they give me 1. Over here, I'm going to multiply by x plus 7 in the top and the bottom. Notice how all 3 are all the same denominators now. Okay, so notice how this still is 1. This is still 1. Okay, and this still has that x over 7. And this still has that x over x plus 7. We just want everything to match up with all of the denominators. So I always take my denominators and I just multiply them out. Okay, now I'm going to make this look not so ugly. So over here, I'm going to have 7x over 7 times x plus 7, right? Over here, I can take everything and kind of smush it together. I'm going to distribute this 7 out, though. And that's going to give me 7x plus 49. Plus, I'm going to distribute this x squared plus 7x, all over 7 times x plus 7. Because if I have the same denominator, I add the top and keep the bottom. Okay? Now, these don't look the exact same on both sides, and even if I condense it down, it's still not going to be the same thing on both sides. So this is going to be false, right? Okay, and if I didn't want a denominator of 0, though, like let's say that the top was the same. If I didn't want a denominator of 0, then I would take my denominator and set it equal to 0 and then solve it out. Okay, and then that would be the number that I don't want to plug in because it would give me an undefined answer. All right, so let's start on what today is about. Okay, so it says, let C be the function that gives the average cost per book, C of X in dollars, when using an online store to print copies of a self-published paperback book. Here's a graph of and just in case you can't see it, 120 plus 4x divided by x. Okay, so it says, what is the approximate cost per book when 50 books are printed, and then 100 books. So total books printed. So I'm going to look at when x is 50, what approximately, and we're just looking at approximate, what is approximately the number of books. Looking at the graph, it's going to be roughly around here. And I'm not really sure what that number is. So even if I'm unsure about the graph, I could take 50 and I could plug it into this equation right here, right? So I could go into my handy-dandy calculator. Sorry. Screen keeps freezing now. And I could be like, hey, calculator, I'm going to plug 50 in for x. So I'm going to do 120 plus 4 times 50. 4 times 50, right? And make sure you use parentheses, and then divide it by 50. That's going to be roughly 6.4. So if I'm like saying how many books approximately, I would probably round down just because, 6.4 is about halfway. But you could also, depending on what your answer choice is, it could be 7. Best answer is probably going to be 6 because you can't have half a book, right? So, I'm sorry, this is cost, so you can have 6.4. So this is my approximate cost. So when it's 100, I'm going to go over to where it's 100, and that's roughly 5 point something. But again, if I'm unsure, I'm going to go into my calculator. I'm going to be like, hey, 120 plus 4 times 100, and then divided by 100. And that's going to give me 5.2. Okay, so if I'm ever unsure about this, I can always go into my calculator and plug it in. So the author plans to charge $8 per book. About how many books should be printed to make a profit? Okay, so the author plans to charge $8 per book. So I'm going to look at when you've got $8. So then I'm going to look at how many total books should be printed. And so that should be about 25, right? And even if I'm unsure of that, I can set my function equal to 8 and then solve. So, again, I could look right here. I could be like, hey, roughly 25, or I could be like 120 equals 8. And then I could solve this mess. So, I'm going to solve it by hand, because again, I want to be kind of accurate. I would multiply by x on both sides, because I want to get x out of the denominator. And then I'm trying to get x by itself, so I'm going to subtract 4x on both sides. And then I'm going to divide by 4 on both sides. And so that's going to be x equals 30. Okay, and I said roughly 25, but obviously I want to be the most accurate. Okay? It then says, what is the value of c of x, so that's your y, your cost per book, when x is 1/2? How does this relate to the context? Okay, so when x is 1/2, so if I print half a book, how much does it cost? Okay, so I'm going to come into my calculator. And I'm going to say All right. If I have 1/2, I'm going to plug it in for x. So I'm going to do 120 plus 4 times 0.5. And then I'm going to divide it by 0.5. And that's going to give me $244. So to print half a book, it's going to cost me $244. Just half a book, right? So $244 for half a book. And so this is representing half a book. This is you've got a 300-page book and you only print 150 pages, right? Now, what does end behavior of the function say about the context? Okay, so for end behavior with rational functions, we've got something that's called an asymptote. Okay, so right here, do we see how it kind of levels off and it kind of looks like it's approaching 4? Like it'll go off onto infinity and it's getting close to 4, but it's never actually touching 4. Yeah, so that is the horizontal asymptote. Okay, so here it is again. And the word that I am saying is horizontal asymptote. Okay, and so an asymptote is something where the function approaches but never actually touches. Okay, so approaches but never touches. Don't touch my asymptote, right? Cool. Okay, so end behavior is where it's approaching at the end. Okay, so we see how it's getting closer and closer to 4, but it never actually touches 4. Okay, so, and the reason why I know that's going to happen, or the reason why I can check this in my graph, so, like, this is a kind of snippet of the graph. If I go into my graphing calculator and I type this function out, and remember, it's really, really important to use those parentheses. And divided by x. And if I go into my table, one thing that you're going to check is eventually it gets, and you might have to change your table set, but it's approaching. I'm going to scroll down a little bit quicker. Table set. Let's go to 500. And then now we're going to go. So it's getting really, really, really close to 4, but never actually touching 4. Okay? Like really, 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 really close, but never actually touches. Okay? So that is what a horizontal asymptote is, and that's how you find it based off of a graph in a table. Okay? And we're just looking at this top portion. Okay? So, end behavior, meaning that it's approaching a cost of $4 per book. So, as you spin or as you print more books, you're going to reach an approximation of $4, or it's going to get really, really, really close to $4 per book. Okay, so we see how it's leveling out, and that's what's going to happen for our cost per book. All right, so again, horizontal asymptote is where it approaches but never touches. Remember, horizontal means across. Remember, horizon, or where the sun like rises and falls, right, is on the horizon, right? All right, I'll catch you in the next video.